Hi, here in this video we will look at the different number types in Julia. So we will start with just simple numbers, the integers, and for example d2, this is an integer, and this integer we can save in variables, so we just create a variables named var and save 32 in this var. By pressing Shift Enter, we have saved this. Okay, just let me restart the Julia console. So here in this section you have all the Julia stuff, and then you can stop Julia console and everything here will clean, and then you can just press enter here and then everything is new. So we will start over and save the var 32 in this variable var, and then we can look at different things. So for example, we can type of var, and then by pressing Shift Enter we'll see that this one is an int 64. When for a second var, something like that, 34, and now by type of var2 we'll get that's a float 64. So then if we add these two variables, for example var3, var1 plus var2, we will get a third variable, and then we get this variable as float, so the int will get promoted to float. And Julia has lots of different number types. Here you see that Julia has like the most abstract thing is just a number, and then you have like complex number and real numbers. And complex numbers you can have like real and imaginary part, and both of them must be type of real. And then in the reals you have lots of different reals, like big float, float 16, and so on until float 64. Then integers, rationals, irrational rationals, and so on. So now we will look at all these different number types, or the most important of them. So if you want to have a complex number, C for example, you just write 1 plus 1 em for imaginary part. Now we have a complex number. Pressing Shift Enter, we have the complex number, and so by calling the function type of C, we'll see that's a complex number and the real and imaginary parts are int. So now we create a second complex number and call C1 and say it's float 1 and 3 imaginary parts, and then by calling the function type of C1, we'll see that now it's a complex number and the real and imaginary parts are float. Julia is written in Julia, so when you want to see how things are done, you can just write at which, and then you can, for example, to create an imaginary number, and then Julia will give you the location where this is implemented. So now you get the location of the plus function, and now we can go there, and we can scroll all the way up, and then we see how the complex number is programmed in Julia. So you have a struct with a complex number. Struct will later on what the struct is and how it works. But the important thing that is, like, you have a real and imaginary part, and here you can see how the Julia programmers did everything. And here, for example, you can get the real part of the complex number just by calling the function real. We'll see that, and the imaginary part with the imag, and so on. And all the functions, for example, power and multiplication and logarithm, everything, and even the is equal is implemented in Julia, because you have to compare the reals and the imaginary parts to see if it's equal. Yeah, so now we see how it's implemented, and we can add here a real with a complex number with this plus, and then we get a complex number back. Next thing is just reals, and the reals are floats and integers. That's what we seen up here. And then we have big integer and big floats for calculating with very big numbers. Now we can see a couple of functions. So first function we saw is just plus. So plus is a function. We can call plus, like in every program language you have the name of the function, it's plus, and then have 2 arguments or more arguments. You can say 4, 5, and then you get plus 4, 5, but also you can do 4 plus 5. You can do it in line or with a function. And minus is also a function, 4 minus 3, but you can also do it in line, or minus 3. The next thing you can do is to see if 2 things are equals. For example, 3 is equal to 3. That's true, but also 3 is equal to 3.3. So just look at the numbers, not about the types. If you want to check the types as well, you have to do 3 equal signs, and also 3 plus 0 imaginary part is equal to 3. So you have equality on the numbers and not equality on types, but you can do it on types as well if you want. Then you have to use 3 equal signs. Next functions are multiplying, so you can multiply 2 numbers 4 times 3 or 4 times 3, that's the same. And division is done just like that, 3 divided by 2, 2, or you can also do it like this, 4 divided by 2 is also 2. If you want to have an integer division, you use the function diff. So you have 10 divided by 3, you will get 3. So if you have 10 divided by 3, you will get 3.333, and so on. But an integer division is get only the whole numbers, that so that The result times 3 is smaller than 10, but you can't add another 3 to it. So this would be much bigger than 10. And so 3 times 3 is 9, so there's the remainder of 1, and you get the remainder as in every programming language just with the percent sign. So the remainder is this function, or if you want to write it in function, you can do it like this. So because everything is the function, and like you can type of a function and do like something like this, and then okay, should get something like a function back, type of, okay, yeah, okay, 10, 3, so this remainder function type of remainder function. Okay, so because everything is a function, you can do fin. You can put all the functions in there. So we have plus, we have minus, we have multiplication, division, remainder, integer divide, and so on. All these functions you can put in an array. We'll see what it is later on, but for now it just takes one function at a time and goes over this block, and then we can print on the console. So we will see the result here and do f of two numbers, 10, 3, and we can evaluate it, and then we get 13, because 10 plus 3 is 13, and 10 minus 3 is 7, 10 times 3 is 30, 10 divided by 3 is 3.333, so on. Then the remainder, 10 remainder 3, 1, and 10% 3 is 1, and the integer division is 3. Other function you can use, just sine, we can sine 0 or cosine of 0, then exp, exponential function, or logarithm, and so on. All these functions are, you can just call them on all the numbers. Floor, or for example, if you have 3.33, the floor is just 3, and you'll get 3.33, and it's 4. Then another special number type are fractions. So you can do something like 3 divided by 5, and it's just 3 over 5, and then you can add them 2 over 1 to 3, and then you get the result as a fraction back. So this is very neat if you want to calculate very accurately, and with the numerator or denominator you get the denominator of the fraction. So if you write denominator of a fraction 3 divided by 8, you get 8. Yes. So the fractions are also implemented in Julia. So you want to check out how they implemented them. You can just go to rationals, and then you see just a struct with a numerator and denominator, and then you have a couple of functions, and function // with an integer and rational, or rational and integer, and so on. And so for example, you can do something like this. You can say this is a, and I can do something like a divided 5, and I have to define what a is, and then I get a rational back. And here you can read everything about rationals basically in Julia. So you learn Julia, you can understand all the data structure because everything is written in Julia. Yeah, I think it's a good start. I hope you enjoyed this lesson and learned something. See you next time.